for our first problem, the rotating blade of a blender turns with constant angular acceleration 1.50 radians per second squared. How much time does it take to reach an angular velocity of 36 radians per second starting from rest? And for letter B, through how many revolutions does the blade turn in this time interval? So in order to solve this problem, we need to follow the problem-solving strategies for rotational kinematics. So the first thing that we need to do is to examine whether we can apply your rotational kinematics in this problem. And as you can see, you have the keywords rotating blade. So therefore, this is an example of a rotational motion. The second one is we can sketch in order to identify exactly what we need to determine. So let's draw your blade. You have the blade of a blender. So let's say that is the blade of the blender, and that is rotating this way. So let's just assume, since it is not stated in the problem. Now, after sketching, we can make a list of the given and then the required. So we have the constant angular acceleration, which is 1.5 radians per second. And we also have the angular velocity, which is 36 radians per second. Excuse me, angular acceleration is radians per second squared. Now, since it is stated here that it started from rest, then 36 radians per second is final velocity, angular velocity. Our initial angular velocity will be 0 radians per second. Now, for letter A, we are being asked about how much time. So, we are looking for your time. Now, after making a list of your given and identifying what is asked or what needs to be determined, we can now choose or solve the appropriate equation. Now, in order to choose your appropriate equation or your applicable equation, you will just do what we did in your linear motion, which is we do the elimination. So if you do that, you will find out that you can use the first equation that we had, which is omega f is equivalent to omega o plus alpha time. So this is the formula that you can use. So omega f is 36, omega o is 0, plus alpha, which is 1.5 times time. So using your calculator to calculate this, to solve this, you will have time is equivalent to 24 seconds. Okay? So rotating from rest to 36.0 radians per second took 24 seconds. Now for letter B, since we are being asked about how many revolutions does the blade turn in this interval, please take note that revolution is a unit for rotation angle. Okay? So what we need to find first is the total distance covered by your blender using the given that we already have. So again, choosing the formula using elimination, you can see that the formula that we can use is theta f minus initial theta is equivalent to omega o times time plus 1/2 angular acceleration times square. Okay? So please take note that when using this formula, what you will get is radians. But you can simply convert it to revolutions using the relationship, which is 2 pi rad is equivalent to 1 revolution. Okay? So let us substitute. So theta f, that is the unknown, minus, of course, it will start from 0, equivalent to, this one will simply become 0 because your initial velocity is 0. So you have 0 plus 1/2 times alpha, which is 1.5, times t squared, which is 24 squared. Okay, so using your calculator again, your theta f is equivalent to 432 radians. Okay, now again, that is not the question. You are being asked to find the number of revolutions, so we still need to convert. So converting 432 radians using your factor, so 1 revolutions is equivalent to 2 pi radians. Okay, calculating, you will have 68.8 revolutions. Okay, and this is now your answer. This will now be your theta f. Okay, so for the next problem, we will have more examples on this.